Emily and Sarah are participating in a charity walk. Emily starts walking from her house at 8 a.m. at a speed of 4 miles an hour. Sarah starts walking from the same house at 9 a.m. at a speed of 6 miles an hour. At what time will Sarah catch up to Emily? So we are looking at distance equals rate times time, and we're looking at two different people. You've got Emily and you've got Sarah. Okay, Sarah, Sarah. That's a song. Now, Emily, we don't know her distance. Okay, so we'll just keep D for distance. We know her rate is going to be 4 miles an hour, right? Yep. And what we also know is her time is since she left at 8 a.m. and Sarah left at 9 a.m., if we say that Sarah's time is T, she has 1 hour on her. So we'll say 1 plus T. Okay? Now, Emily, her distance, we don't know. We know that her rate is 6 miles an hour, and her T is just regular. Okay? Emily has an hour on her because she started an hour earlier. That's where we get the 1 plus T. Now, if I were you, I would set these two. This is, system of equations. And since D equals this and D equals that, then we could say this equals that. So how about 4 parentheses 1 plus T equals 6T? I don't need to keep that in parentheses. I'll leave it right there. Okay? Distribute. 4 times 1 is 4. 4 times T is 4T. That equals 6T. We can subtract 6 from both sides. I always like getting rid of the guy on the right, and a lot of people will be like, no, I'm not going to do it that way. This is the way I do it, and you're going to watch me. Okay, so that's how we get it. Subtract 4 from both sides. I'm running out of space, so up here I'll write out negative 2T equals negative 4. Divide both sides by negative 2, divide both sides by negative 2, and T equals 2. So T represented Sarah's time. Sarah left at 9 a.m. So 2 hours after 9 a.m. is going to be 11 a.m. and that's when she caught up. Tricky problem, very strange. Also as strange as me trying to draw a circle and not completing it, but that's how you do it.